So hey everyone, welcome back to our channel. This is our single lecture of chemistry for the structure of atom. Now, to master the concept of this chapter, you need to start watching our videos from beginning. That's why I suggest you to watch the mole concept video, because that's the fundamental basis of all the chemistry topic, mainly for physical chemistry. Now for the note, as I have suggested, you should follow either our Pinterest page or subscribe to our Telegram channel. Let's begin with the basics. We are studying the structure of an atom. For that, we must understand what an atom is, what are its components, what are the basic hypotheses or the contribution of different scientists about their postulate regarding the atomic structure. First, you need to understand what an atom is. Each element is composed of the smallest particle called as atom. The name atom is derived from the Greek word atomos, which means not to be cut. That is, atoms are indestructible, or they can neither be created nor be destroyed. It consists of electron, proton and neutron. Electron is negatively charged particle, proton is positively charged particle, whereas neutron is neutral atom. The charge of electron and proton is same, but their direction, or simply says as polarity, is different. The mass of one electron is 9.1 into 10 raised to the power minus 31 kg, whereas the mass of one proton is 1.6 into 10 raised to the power minus 27 kg, and mass of neutron is 1.00899 AMU, atomic mass. Charge mass ratio or EM ratio. J.J. Thomson determined the charge to mass ratio of electron by measuring the deflection under the influence of both electric and magnetic field. Now, just you have to remember this order. The specific charge of electron is greater than proton, than that of alpha particle, than that of neutron. It is denoted by ZXA. The proton and neutron are referred as collectively as nucleons, as they lie inside the nucleus, whereas electron revolves around the nucleus. Iso means same. An element with atomic number Z and mass number A can be represented by this structure, where A means mass number and Z means atomic number. What is mass number A? Mass number is the sum of the total number of proton and neutrons in the nucleus. What is Z? Atomic number. The concept of atomic number was introduced by Moseley. The atomic number denotes the number of protons in the nucleus. The number of protons in the neutral atoms equals to number of electrons. Let us understand about different atomic species. First, you need to understand one thing, that is iso means same. Now, first one is isotopes. F. Soddy was the first person to discover isotopes. Isotopes share same atomic number, that is Z, and they have different mass number. As their atomic number is same, that means they share similar chemical properties but different physical properties. For example, for hydrogen, protium, deuterium and tritium is an example of isotopes. Now, what is isobar? Isobar are atoms that share same mass number but have different atomic numbers. Isobars are atoms of different elements with distinct physical and chemical properties. That is, neither their chemical properties nor their physical properties matches. Isotope. Now, let's understand about isoelectronic species. What is isoelectronic species? For an either charged particle or non-charged particle, if they contain the same number of electrons, they are said to be isoelectronic species. Now, let's begin to study about the main portion of this chapter, that is models of atoms proposed by different scientists. First, you need to understand about Thomson plum pudding model. Thomson was first person to propose a detailed model of atom as watermelon model or plum pudding model. You can just visualize it as watermelon with the red portion as positively charged particles and seeds as or black portion as the electrons, which are present as some place. Rutherford alpha particle scattering experiment, or simply you can understand it as Rutherford atomic model. Rutherford carried out an alpha particle scattering experiment by the bombardment of high-speed alpha particles in a thin fold of gold emitted from a radius, and gave the following observation, which were based on his experiments. First, the procedure was executed. He executed a number of experiments involving the scattering of alpha particle, helium plus 2 ion, by a thin fold of gold. Observations were The observation of Rutherford alpha particle experiment was most of the alpha particle around 99% passed through without any deviation. Some pass with little deviation. Majority, very few particles were deflected by large angle. Occasionally an alpha particle got deflected by 180 angles. The application of Rutherford atomic model is to determine the distance of closest approach. The drawbacks of Rutherford atomic model: it does not obey the Maxwell's theory of electrodynamics, failed to explain about the discrete series. Now, the particle nature of electromagnetic radiation. First, you need to understand these two trends. For as we move from violet to red, the wavelength of particle increases and frequency decreases. As we move on from cosmic ray to infrared rays, wavelength increases and frequency decreases. Just remember this order. Now the most important thing, that is Bohr's model. The atomic model proposed by Niels Bohr, which was based on Planck quantum theory of radiation. It simply stated that the energy of an element remains constant as long as it stays in same orbital. The same orbital is said to be stationary orbital. The failures of Bohr's atomic theory: he was unable to explain the splitting of spectral line in the presence of magnetic field, that is Zeeman effect, and electric field, that was Stark effect. And he was unable to explain the line of structure of multi-electron atoms, which contains more than one electron. He was even unable to explain the atoms in three-dimensional existence because of the dual nature of matter and uncertainty principle. Because the dual nature of matter proposed by de Broglie and uncertainty principle proposed by Heisenberg, the Bohr's model failed. But jump of electron in orbital, the change in energy is represented as upper frequency minus lower frequency multiplied by Planck constant. The number of photon transition was given as n minus 1 divided by 2, where n means the number of orbits. And you can memorize these all formulas which are necessary for the calculation of numericals. And Bohr models suggest energy levels are discrete, not continuous. Here is an hydrogen spectra. Hydrogen spectra starts from Lyman series, Balmer series, Paschen series, Brackett series, Pfund series. Now, the energy is given as in electron volt unit, where the electron energy limit of Lyman series was minus 13.6 eV, Balmer series was minus 3.4 eV. Number of spectral line. For example, for Lyman series, these are known as the spectral lines. Is given as del n multiplied by del n plus 1 divided by 2, where del n means n2 minus n1. That is quantum mechanical model of atom. The formulation of quantum mechanical model atom were based on two major concepts that were of dual nature of material object by de Broglie's hypothesis and Heisenberg uncertainty principle. In 1924, de Broglie proposed the matter that acts as both a radiation and as both particle and wave. According to de Broglie, the wavelength associated with particle of mass m and moving with velocity v is given as lambda, that is wavelength, equals to Planck constant divided by momentum, or you can simply say this mass time velocity, or by equating it from kinetic energies formula, you can simply understand this. And if you balance the kinetic energy for electrical energy, you can carry out this formula. And if you put on the value of constant, you can calculate it as lambda equals to 12.24 Armstrong divided by under root of v. What is v? The particle velocity. What is v? The moving velocity of that matter. Now, for the number of waves, you can calculate it as 2 pi r equals n lambda. Heisenberg hypothesis or Heisenberg uncertainty principle. In 1972, Heisenberg proposed out in the calculation of position and momentum of a microscopic particle at the same time is impossible with absolute precision. That means if you are calculating the position and momentum, it will be the error in this calculation which will be greater than h divisible by 2 pi. For similarly, you can calculate, or simply if you can deduce this, that is energy times time. These are the common properties for Heisenberg uncertainty principle. Now, what is Schrodinger's wave equation? This is the Schrodinger's wave equation. Majority time it is asked which one is Schrodinger's equation, so you need to remember this formula only. If you want a detailed video for Schrodinger's wave equation, you can comment down below. I will bring that for you. Now, let us understand about the electronic configuration of element. What is electronic configuration of an element? It is simply an arrangement of element in various shells, subsets, or orbitals. The following rules govern the filling of orbitals. First, main important rule is above principle. The principle was proposed by Niels Bohr in early 1920s. The principle was a tool for obtaining the picture of atomic constitution, that is arrangement of electron on orbit around the nucleus. It simply states that elements are filled in higher energy first and then filled in lower energy. You need to understand these following important points. Now, paper terms. Now, atom is consist of three particles, that is electron, proton and neutron. Electron was discovered by J.J. Thomson. Proton was discovered by Rutherford. Nucleus was discovered by James Cardick. You can remember their name by this mnemonic, that is ETPRNJ. Orbitals failed because it failed to explain about the different things. Now, what is orbital? Orbital is a space around the nucleus where electron lies. Now, first order, S orbital. It is a spherical shape. It has simply one shape, that is S, and you can just remember it is not in circle but in a sphere. Now, P orbital. P orbital is of dumbbell shape. It has three subcategories, that is px orbital, py orbital and pz orbital. For px orbital, I have given as the shape of p orbital as a dumbbell shape. Now, d orbital. D orbital is of double dumbbell shape. It is of dx square minus y square, dz square, dxy, dyz and dzx. For dx square minus y square orbital, I have given as that one. The quantum numbers. There are four types of quantum number: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Principal quantum numbers give the information about shell, orbit and energy, and it is denoted as n. For KLMN subcells, it is n for 1 for K, L for KLMN orbital. Their value of principal quantum number is 1, 2, 3, 4. Now, the number of electron in an orbital is given as 2n square, where n is n. Now, what is azimuthal quantum number? It is denoted by L and it gives the information about this subcell. That is, for SPDF orbital, the azimuthal quantum number is 0, 1, 2, 3. Now, what is magnetic quantum number? It is denoted by M and it gives the information about orientation and orbital. It gives the information about orbit only. That is, principal quantum number gives the information of orbit and the orbital's information is given as magnetic quantum number. Magnetic quantum number ranges from negative of azimuthal quantum number to positive of azimuthal quantum number. Number of electrons is given as 4 times of azimuthal quantum number plus 2. Now, what is spin quantum number? It just give about the spin nature of electron. It can be either of plus or minus half. Maximum number of electron that it can accumulate is 2n square. Same value of n. Energy for subcell SPDF increases gradually. Maximum number of electron in a subcell is 2 times of 2l plus 1. That is, number of electron we can calculate as 4 times of azimuthal quantum number plus 2. Simply that formula. Orbital angular momentum is given as Planck constant divisible by 2 pi under root of azimuthal quantum number into azimuthal quantum number plus 1. Now let's learn about this further. 2 more explanation for filling an electronic configuration. Pauli's exclusive principle. According to this rule, no 2 electrons in an atom can have same value of all 4 quantum number. The Pauli's exclusion principle helps to explain a wide variety of physical phenomena. Electrons have to stack within an atom, that is, have different spins while being at a same electron orbital. Simply, 2 electrons present in same orbital have same energy and same value of principal, azimuthal and magnetic quantum number, where their spin quantum number varies as positive and negative of half. Now, Hund's rule of maximum multiplicity. According to Hund's rule, According to Hunt's rule, orbitals available in the subshell are filled singly with a parallel electron spin before they begin to pair. That means pairing of electrons occur with an introduction of a second electron. That is, first electron are filled empty in orbital, then they are paired. Now you need to memorize these two atomic number of two elements, that is bismuth and radium. For the atomic number of bismuth, it is 83, and atomic number of radium is 76. Now this is our last portion of our chapter, that is some fact regarding to the atomic structure of an atom.